This problem is about mean, median, and standard deviation. And so let's see, let's take a quick look over the questions, and we'll move to the second slide where we can do the work. We've got sample data here, so we're working with a sample, not a population. We've got a data set here to work with of some items, but they're not sorted, so that's going to be one of the first things we want to do is to sort those data points, low to high, and count how many there are and sum them up. And we do that for a couple of reasons. We've got to get the mean and the median, so we need them sorted and in order for the median, and then we've got to calculate a standard deviation as well for this. So we've got a few things to do as far as calculations, and then a couple of parts C and E, where we explain what it is that these calculations are for, or what we're using them for. All right, so let's look here. It's in a little bit easier format for us to work with, and I've got the standard deviation formula over here, and we'll just walk through that using, this is the shortcut method, I think is what it's referred to as. It's a little bit easier to work with, I think. And then here we've got our sorted data right here. So here, and if you count up the data points here, n is 10. There are 10 of those. And if we add these all up, we have 40. Okay? 40 is our total. And so looking at that, then we have a 40 is the total of our 10 data points. So if you divide 40 by 10, right, our mean is going to be 40 over 10, or 4. Okay, so the mean number of restaurant visits is what we're looking at here. It's not 40, it is 4. All right, so that is our mean value. Okay, now the median, right, when we have our data points here, we have 10 as you recall, and so if we were to divide this into 2, we would have, for the median point is going to be when we've got an even number of data points here, it's going to be the average between our 5th and 6th data point. So we would say 3 plus 5 over 2 is also 4. Okay, so that's that dividing point, right? 4, and that's going to be the midpoint. So we're going to have 5 points below that and 5 points above, and that is our median. Okay, now if it will let me, I'm going to erase that just and put it in another spot because we need to use. Okay, so our median is 4. Median and mean are 4 here. All right, now in this case here, we're asked in one sentence indicate under what conditions the median is preferred over the mean as the measure of center in a data set. Okay, and the primary purpose you would use a median instead of the mean is if you think there are outliers in the data set, or if there's very high or very low values. For example, if instead of 9 our last value was 150, that would be a reason that... All right, sorry, I was interrupted by a cell phone there. Okay, so I think I was saying if this last number instead of 9 was 150, right, that would be a fairly large outlier. That would skew our median, our mean, but our median would remain the same, and so that would be the reason that we would want to use a median instead of a mean if we thought there might be some outliers there. And housing prices, as discussed in class, is a typical time when we would use median. Salaries is another one where there can be sort of exponential salary growth at the executive levels perhaps, but you might want to separate that out. So again, that would be if they expect outliers, then you'd use a median. All right, so part C we've done, okay, and then part D, determine the value of the standard deviation for these sample data. Okay, so we're going to use this formula over here, but I think it's easier to walk through than it is to look at, perhaps. And so, if you recall, this is a sample, right? And so the biggest difference here when we're working with a sample is that this denominator here is going to be n minus 1. So that's going to be, when we get to that point, is going to be 9, right? So 10 minus 1 is going to be 9, okay? So we'll just keep that in mind. So if you recall, the general steps for creating this are you square each of these values and sum them, okay? So that's this part. Then you square this sum here and divide by n, okay? And then you divide that. We'll divide all that by 9 and take the square root of that to get the standard deviation. Okay, so let's do that first. So we'll do this first part here. We're going to square each value. So 0 squared is 0, 1 squared is 1, 2 squared is 4, 2 squared again is 4, 9, 25, 25, 36, 49, and 81. Okay, and then we add all of that up. And we get 225, I think. Excuse me, we get 234. 234. Okay, so if we were to draw this here, let's say S is going to be 234. Well, if I could write, it would be, okay, 234 minus, and then we would have this 40 squared, which is 1600, over 10, so it's going to be 160 over 9. Okay, so if we do that, then we get S is going to be the square root of 8.22, and that then the square root of 8.22, then S is going to be 2.867. Okay, so that is the answer to part D. Okay, so again, we took the each of our values, each of our data points, and squared it, summed that up. That was a 234. We then took the sum of all these, which was 40, as we did earlier, squared that, and divided by n. Okay, and that's just n, not n minus 1 there. So 1600 over 10 is 160. Then divide by n minus 1 because we've got a sample. That comes down to the square root then of 8.22. So that's actually, without that, if we said s squared, that would be the variance. So the variance is 8.22. And then our standard deviation then is 2.867 restaurant visits, right, is the standard deviation. So we could say then our mean was 4 plus or minus 2.867 or 2.87 restaurant visits. So somewhere between, you know, what, 1 and a quarter, or 1 and 1.15, we'll say, and 5.85 or 86 restaurant visits would be sort of the range that we would expect within one standard deviation of that as our results. Okay, and then in one sentence, again, I mentioned in another video why I ask for one sentence. Don't try to answer it in multiple ways, what it might mean or what it might not mean. Just say in one sentence, very simply, what the standard deviation means, and a good answer for that would be that it measures the dispersion of data around the mean, how widely varied the results are within your sample. Okay, and again, the standard deviation is better than the range. Here the range would be 9 minus 0, right, would be 9. But that doesn't really tell us anything about all the data points in between. The nice thing about standard deviation is it uses all of your data points and comes up with what is essentially an average of how widely varied the data are.